Hello. I am so excited to be in Israel and in Tel Aviv for the first time and in a hotel where my name is everywhere. If there's one thing I learned here so far, it's that I do not know how to pronounce my own last name because I've had so many people correct me, so that's great. So I'm going to be talking today about forms. Forms are one of the worst parts of web development and application development. It doesn't matter if you're doing native development or React or Angular or anything, they're just terrible. And I'm going to tell you why they're terrible and what we can do about it. So, a few years ago, I wrote a form library. And I wrote a form library because I thought it was a good idea at the time. I was playing around with Redux form, and I saw that it didn't have everything that I wanted to do. Plus, I was fresh to React, or sort of fresh, and I was coming from Angular version 1, which actually had a really nice way of handling forms. You just put the model of what you want to edit and the input or the control or buttons. They handle it automatically. But I soon realized that writing a form library is a bad idea. Just ask Kent Stodds, just ask anyone who's written a form library before. So, first of all, the name was a bad idea. I wanted it to be similar to Redux form, so I named it React Redux form, which caused a ton of confusion. In fact, a lot of issues for Redux form were in my library, and a lot of issues for React Redux form were in the Redux form repository. So it did cause a lot of confusion between React Redux form and Redux form. Plus, look at all those issues. That's a sign of maintainer fatigue. I just did not want to work with it anymore. Using strings, like in Angular version 1, was also a bad idea, especially because, now that I learned TypeScript or other people are using Flow, we just know that strings cannot be strongly typed. In fact, using Redux alone was a bad idea. And there's many reasons for this, and I don't know if Mark's in the room, I'm sorry, but so using Redux for form state was a bad idea. If you're using Redux, that's totally fine, but for form state, there's better options. And here's why. With Redux, Redux has this idea of a global store, a global single atomic store that holds all of your data, especially states that involves multiple components communicating with each other. Local state, on the other hand, has localized states where each part of the tree has its own local concern, and it instead communicates via passing props or calling callbacks with parents' components. The problem is, when you're using Redux, you're still not fully using this global atomic state because you might have third-party components such as this control, which already has its own local state. So you still have state spread out through your app. It's just a little less organized and less predictable than just having everything be local. So Dan Abramov, of course, he was one of the creators of Redux, has stated himself that you should use React for ephemeral states, which is state that's just passing or local or only relevant to the components at the time of render, and use Redux for state that matters between components or between separate concerns, so state that matters globally. And finally, he said the rule of thumb is just to do whatever is the least awkward thing to do. In other words, be idiomatic. So, thank you, Dan, that's great advice. But handling state in multiple ways was a bad idea. Because once you have multiple different ways of handling state, things just get sort of messy. I mean, just ask Israel. Anyway, Formic. So, Formic is one of the largest, or not largest in terms of size, but one of the most popular form libraries for React right now, and it includes a lot of helpful utilities for handling forms, handling inputs, handling whether something is being submitted, handling validation, and it does so in a way that's unobtrusive and lets you have control over your form for the most part. React's Final Form is another popular library, which is based on Final Form, which is sort of an iteration from the previous Redux form. It's the same creator who, surprise, he abandoned Redux form as well, just like I abandoned React Redux form. And if you look at both of these libraries, you'll see something very similar. you'll see that it includes this magic render component or something. I think they're going to start using hooks now, but regardless, the idea is the same, where you take props, you pass it into these inputs, and you don't care what's in these props. That's a good thing and a bad thing. Number one, it's a good thing because you don't have to care. You just put it there, and things magically work. It's a bad thing when you want to control how things work. So I recently saw this tweet by Sam Saccone where he describes what should be a simple form. And it's sort of a wizard form. So we have 3 inputs which depend on each other. So you could think of it as having a step 1, step 2, step 3. And then each of these steps has asynchronous validation, which is already a scary thing. And then once you submit the form, you have a loading state, and then you have either a success state or an error state. And if your form submission fails, you should be able to retry. Very simple, the requirements fit in the tweets, but still, this is difficult to do, even with the existing libraries. And so the reason why is because, for some cases, using a form library is actually a bad idea. So for trivial use cases, you could simply use React's local state, and that's fine. But once you get into a little bit more complex use cases, then you start thinking, maybe we should go and reach out for a popular form library such as Formic or React's final form. But then once you want to start escaping whatever those libraries enable you to do and start saying, I have specific needs that this library doesn't address, then the libraries actually make it harder to accomplish your goals. Whereas if you just went the approach of not using a form library at all, then it might be simpler. An emphasis on might, because without properly modeling our forms, which is what we're talking about today, things can also get messy. So either way, whether you're using a library or not, you're sort of screwed. And I'm going to show you why. So let's take this async validation example. For example, we had the value and set value, and we're using state. So just very simple React hooks. Who of you is using hooks? Hopefully all of you. Yeah, if not, migrate. It's a really good thing to do. But we want some sort of validation state. So we have another use state for validation too. And we want to validate on blurs, so we just set it over there. And let's see. So we also want to set validation based on async validation. And since we're doing it on blur, we have async validate in the onBlur event handler. Not too bad, right? But also, we want to be able to conditionally show or hide whether the input is valid or not, and color it, based on that. So we have this touched or set touched property where touched means if you actually focused on the input, then only then should it be touched, and you should show the validation, etc. And of course, you have to have things where handled true or false. And then let's say you want to handle cancellation. I don't know if you could see that. Let me zoom in for you. You want to handle cancellation too, so then you have a use effect, and then you have all of that in there. So this gets really, really frustrating, and that's only part of the problem. So let's say we have a form, and I've run into this issue so many times. And let's say your form has a submit button or a fetch data button. The idea is simple. You click, it does some sort of asynchronous request, and then it finishes. So what if you click and it takes a long time? You want to show some sort of loading spinner. Okay, that's not too hard to do. You have this loading flag. But what if you click and you're like me and you get angry and you think that clicking the button multiple times makes it faster somehow? Now you have 5 API requests, and you definitely want to prevent against that. So you're a developer, you're smart, you think, I will disable the button, and that way they cannot click it many times. But if you're also like me, you know that there's such thing as DevTools, which you could open and undisable the button, and then the logic is the same. So this is known as the bottom-up approach, where we stuff so much logic into our event handlers, and this is where complexity lies. We don't have a centralized place of handling our application logic. It's just spread out through all of our components and all of our events and just random areas of the app. And so this bottom-up code becomes very difficult to test because you are not entirely sure what's happening in your app. It's also difficult to understand because you cannot communicate clearly to another developer, much less a designer or your manager or any other stakeholders, what's going on in your app. This means that your app will contain bugs. It's a statistical probability because there's so many different combinations of things that the user could do to your app and so many different ways that things could go wrong. In fact, it's difficult to enhance because if you want to add a feature that might touch one area of your app, in fact, you might need to add that to many parts of the app where logic is contained. And since your logic is contained everywhere, you're touching many areas of the app. And so features actually make it worse because it increases the state-based size of your app in which the user could interact with your app in even more ways. And so there's even more cases where bugs can happen. So one way that we could tackle this complexity is with a mathematical model called finite state machines and statecharts, which is an extended version of finite state machines. Now, some of you might have taken this course in college classes and have been bored out of your mind. It's actually not too hard of a concept. So, finite state machines have 5 parts, and this might be reviewed to some of you or might be new. So a finite state machine has one initial state. So let's say our initial state's editing. It has a finite number of states too, and this is the important part. This makes it deterministic. It has a finite number of events, which are the possible things that could happen to the machine. Whether this machine represents a single component or your app, there's only so many things you could do to it. And so we also have a mapping of transitions that say when we're in a state such as editing and the submit event happens, now we're in the submitting state. And we also have a finite number of final states, which tells the machine we're done. This is our final state, and that's it. So if we take a look at a simple form input, we could see that there's many possible states that this input could be in. It could be disabled, enabled, pristine, dirty, focused, blurred, valid or invalid, and many things can happen to it. You could change it, focus it, blur it, and if you have custom components, you could do even more things. The main idea that I want to express to you is that every single component and every single part of your app, whether it's tiny or composed of many components, can be expressed in terms of these states and events. So for example, your input is a state machine because in order to go from one state to another, an event has to happen that causes that transition. So for example, your input might be blurred, and when you have a focus event occur, now your input's focused. And so this doesn't matter whether you're on the web or on native, it's still the same idea. The implementation details might be different, but the idea is there that you have a focus state, blurred state, change state, valid states, disabled state, etc. And some of these states are exclusive. So you can't be focused and blurred at the same time. That doesn't make any sense. So that's the idea of one possible finite state at a time. Also toggles, such as checkboxes and radio buttons, they're also state machines, and you could imagine just the different ways that we can navigate between the different states of these checkboxes. Now let's get more advanced. If you're familiar with the React State Picker by Airbnb, this is also just a state machine composed of smaller components. So you see, like at first, the state picker is closed, and then when we click Start State, we're opened and we're editing the start date. Once we select the start date, now we're in the state of editing the end date. And once we click that, then we're closed. So this is how React Date Picker works. In fact, your entire app can be described as a state machine. And you could edit this at any possible level of abstraction, but you could consider your entire app as a series of states, events, and transitions that transition between those states. In fact, you could consider yourself a state machine. You're either asleep or you're awake. It took me too long to make this GIF. I couldn't find it anywhere. So in order to express this, we're going to use two hooks. And these are my favorite hooks to use, and these are always in my tool set for any React application I use. It's a combination of use reducer and use effect. So when we're doing things a basic way, where we have an event, and whatever happens in the event determines the next state, we know that that's incomplete, right? We know that the next state depends on what the previous state was and the events that occurred in that state. But that's also incomplete, because we need to depend on the state in an event, and that's going to return the next state and the effects to execute. I don't want any of us to think anymore that effects are just something that happens or something that we have to, consider a last-minute concern, but instead consider effects a core part of how your application works. And so the combination of use reducer and use effects can really help with this. Events are sent to use reducer, which can update the state and give us a combination of next state and effects. We're used to using use reducer to only return the next state, but if we change our thinking a bit and think, what if we declaratively represent the effects that need to be executed as part of the state returned, then the mental model becomes a lot simpler. And so we'll demonstrate this. Let's say we were just using use reducer, and the reducer returns the next state. The problem with this is we want effects to execute. We know we have to execute these effects, but we don't know when they're going to execute. So we don't know what to put in those square brackets, and we don't know what to put inside use effect. Use effect is really weird. It's really confusing, and if you're confused by it as much as me, I feel your pain. So what we could do differently, and this is just one idea. Basically, I just want you to have the idea that instead of just returning the next state, we return a combination of the next state and the next effect. This is not a brand new idea. It's been discussed on Twitter, which doesn't count, but it's also been in Reason React. So if you've played around with Reason, you might have noticed there's an update with side effects, and it has this exact same model. And in fact, this very much resembles the Elm architecture too. So the idea is that your reducer would take the state, it would destructure it, and then it would calculate what the next state and effects are, and it would return that. And so we would take that state and effect, and we would execute the effects in use effect. This means that the effect is based on state, which is a very important concept. And so one idea of this is like we could update a fetching state and also return, hey, you should fetch the data too. I'm using an object in this case, but you could also return a function because functions can be considered objects, or you could use a plain object such as this. And so we're returning both the next state and the effects to be executed, or if there are no effects to be executed, we could just return the state. And so the idea is that we need to realize when effects happen. And they don't happen randomly. There's only 3 possible places that an effect can happen. It can happen whenever a state is entered, whenever a state transitions from one to another, and whenever a state is exited. These are the only 3 places, and regardless of where the effect occurs or how it occurs, it is part of the next state returned. So that's the main idea. They don't occur randomly, they occur as part of states changes. And so this helps get rid of this whole idea that a lot of us use like this empty array to signify effects that should only run once on component did mount, but it's like an anti-pattern that we've accepted, and it's not really the best idea. So instead, we could just base every single state change and every single effect on those state changes, which is a better idea. So let's go back to the original problem. We could model this as a state machine, where we have first, second, and third questions, and when we go to the next state, it transitions between those states. And then when we submit, we go to this loading state. And then some promise resolves, and eventually we go to a success or an error state. And in the error state, we could retry. And so looking at this diagram, which, of course I had to craft by hand, this diagram makes it really clear what's happening in our application and really clear what the features are, what can be done, and how the user could navigate through the application. You could model finite state machines with switch case, where you consider the current state, such as searching, the event that happens, such as resolve, and the next state that's going to occur. But I like using objects just because it's a more succinct way of doing it. And so with objects, you could just model it the same way, where you have searching, use an object lookup to figure out what the next state is based on the events given. And so a simple transition function can take that object and determine, that state. So we get the current state, we get what the next state is based on the event, and if there's no next state or no state defined for that event, then we just return the current state because the machine did not handle that state. So XState is a library that I wrote about 2 years ago that does all of this and more. It does state machines, hierarchical state machines, orthogonal parallel, which I'll go into in a little bit. And the thing is that it takes that object format that we talked about that you could use without a library, and it just wraps it in a machine, which gives you a lot of nice functions and methods for dealing with those states. And so you could also interpret these state machines and send it events, and so now you have a running version of your machine that acts sort of like an event emitter. So sort of like Redux's subscribe, where you send it events and it returns, or it emits new states that you could subscribe to. So let's take our original example, our async validation loading failure success form. First, we describe the states right over here. So we describe our first state is state 1, and all of our states are over here. Then we could fill each of the states with transitions, just like that. So we say like 3 on next loading, 2 on next 3, etc. And we could use another package that I recently released about a couple months ago called XState React. And this introduces a new hook called useMachine. And you could consider useMachine just like useReducer. You give it a machine, in this case the wizard machine that we just created, and you get the current state and a send function. Now I like saying send instead of dispatch just because it's shorter, but it's the same idea. You're sending events to this reducer, really a reducer on steroids, and it gives you the current state and a whole lot more. And so it also includes methods such as matching based on what the state is, and also a nice convenient way to send events back to that state machine. So this is what that state looks like. We have the finite state over here, which is the value. We have the context, which is all of the extra data that doesn't necessarily pertain to the finite states, such as editing, loading, step 1, step 2, step 3, but just data like whatever the user typed in, and actions, which are your declarative array of actions to be executed. So you might be wondering if this scales, and it does not necessarily scale once your app reaches a certain level of complexity, just because you might have multiple states that are redundant, and you might have multiple transitions between those states. And this is known as the state explosion problem. This was a very risky slide to edit at the airport, but yeah. And so the idea is that the more states you have, the more transitions between those states happen as well. So an Israeli computer scientist, a professor named David Harrell, actually created this formalism in the 1980s called statecharts, which are extended state machines. And these make state machines really, really nice to work with. He was working with the Israeli Air Force or something like that on their software for controlling their aircraft, and found that this was a really great way to model the software that controls various parts of the aircraft. So state charts are an extension on state machines in that they introduce actions, which are these side effects that we're talking about, and again, they could happen on entry, transition, or exit. They also introduce guards, which only allow you to take these transitions if these guards are true, and so that's just right over like these conditions. And they also introduce context, which allow an extended state to complement the finite state of the application. So let's take another look at this wizard machine with our async validation. So now we have a bunch of things happening. We have our context, which is the state of each one of the steps, and we also have actions that assign to that context based on the events given to them. So there's also the idea of hierarchy, which is states within states, and orthogonality, which is parallel states. So I'll try to describe each of these real quick. So hierarchical states. If we're modeling each of the steps and modeling this asynchronous validation, over here, our first pass might be we have a validating state, and we might have an invalid and editing state. And we notice that there's a lot of redundancy here, where we have submit from both of those, and edit goes back to editing anyway. So we could instead combine those two states and reduce the number of transitions. And you could think of these as like events bubbling up the tree, because there's a lot of shared behavior, which is what hierarchical states are all about. And so the way that you would make hierarchical state machines is you would just pass the exact same object structure as infinitely recursively as you want through each of these states. And then we add all of the actions here, which I'm going to demonstrate, but I have less than 5 minutes left. And there's also the idea of invoking services, where, for example, when I'm in the loading state, I'm invoking a validator, which is a promise, and this promise can either resolve or reject. And whether it resolves or rejects, it will do the proper transition defined on the state. And one of the beauties of this is when we leave this loading state, if this promise is still going, it will automatically be canceled. So overall, here's a final example of what this validation machine looks like. So let's say I type something here. It will asynchronously validate, and let's say I accidentally make something invalid because I have a number. I could add it again and do that, and then it's loading, submitted, success. So you might be thinking, okay, that's cool, but I could already do this in Redux or MobX or something like that. So one of my favorite things about using state machines and state charts is that you could simply copy your machine definition, which you're using in your app, and you could visualize it. So for example, let's visualize it over here, and let's just resolve this. There we go. And so now we have a visual way of representing our machine. This is almost the exact same JavaScript code that we're using, and we could see that we're going through this machine, and we could validate that our logic is correct. So if we reject instead, we should go to the failure state, and we should be able to retry, which it immediately goes to the failure state, but eventually it goes to the success state. And so that's just one of the best parts about using state machines. So orthogonal states also address concerns where many different parts of states might be active at the same time. And so, for example, if you're modeling like a text picker where you have bold, italic, underline, you could simplify that in these orthogonal states instead of having a combinatorial explosion of states. And so forms and form inputs have this characteristic as well, where we have this idea of pristine, touched, validity, focus, etc., where all of these might be activated at the same time by same events. And so this represents the combinatorial combination of all of these different states. And so, again, there's visualization tools where you could just copy and paste any part of your machine, or any part of your app which is a machine, and be able to visualize it. And the reason that this visualization is possible is because it's based on a formalism called SCXML, which is a very strict definition of what you could do with state machines and state charts. XState also works with the Redux dev tools, as you see here. All you have to do is set dev tools to true in your use machine handler. And XState 4.6 has support for actors now, which I'm not going to get into because that's a completely different talk. But the idea of actors is instead of having one global state, you have many local states which communicate with each other in a hierarchical way, where parents can communicate with children, and children can communicate with parents as well. And also, I have support for observables now in XState 4.6, which means not only can you invoke observables and listen to events as they come in, but the XState interpreter itself is an observable. And so there's many helper packages coming out to XState, including XState View, which I'm sure none of you care about, if that's okay. Including this one, XState FSM, which doesn't deal with hierarchical or parallel machines, but it instead deals with only finite machines, and it comes at a very tiny bundle size. So there's many examples and use cases which you could read about online. If you're using Gatsby, you're already using XState. It's part of the build process in Gatsby, and it's part of many other things. Again, there's this SEXML formalism for state charts, and lots of resources for you. We have a very active community where we talk about how we could better model our applications with state machines and state charts. So in short, I want you to write code that does more than just do the job, but code that could be visualized, analyzed, tested, simulated, and more. And that's what I hope to bring to you with state machines, state charts, and XState tools. So thank you very much, ReactNext.